Hi, everybody, and welcome to the latest episode of the Realistic Business Forecasting podcast. Today, I want to talk about the use of a dummy variable. Before I actually get into it, let me actually give you an example of why we might need a dummy. Now, this is based on work I did not that long ago, and I was plotting the number of train miles which were run against the delays per train. And this is the data I got. Now, at first glance, it looks as though there isn't a great deal of relationship between these two variables. But then I decided to investigate a little bit more. And I noticed that there's a group of points, which you can see with the orange ellipse, which were a bit distinct from the other variables. Now, the data for all points here runs from approximately April 2016 to September 2022. But I noticed that all the points which I've highlighted there are towards the end of that period, so December 2021 or later. So it struck me that there are probably two sets of data here which are combined into one. And the question is, how do we actually separate them? What I'm going to do is I'm going to use a very simple example based on ice cream sales. So the owner is trying to find out whether weekend sales are significantly higher than weekday sales, and more to the point, by how much. Now, if you actually look at this stage, you can see that there is a seasonality effect going on, and every week there is a peak. You'll also notice here that there seems to be a problem. We don't know what it is at the moment, but we're going to also examine that incident as well. Now, the average sales per day, you can see in this table here. You can see that Friday and Saturday sales were rather higher than other days of the week. And what I've done is, for Wednesday and Thursday, I've taken the average of every incidence of Wednesday and Thursday, but I've also looked at the average without the incident. So if I look at the data for all observations, it's pushing down the average because of that problem that we saw in the previous chart, i.e. here. But even without the incident, we can see that Wednesday and Thursday are not really that different from Monday or Tuesday. So what we want to find out is, what sort of uplift in sales can our ice cream parlor owner expect on Fridays and Saturdays? So what I've done here is I've just done a very simple thing. I've added a dummy variable, which takes the value 1 for Friday and Saturday and 0 for all other days. I've omitted the remaining rows, Tuesday, Wednesday, Thursday, for clarity. So let's just run a simple regression of sales against the dummy. And if we look at this data, we can see that we get some good, strong results. We have very low p-values, which means that both the intercept and the dummy are significantly different from 0. So what's this equation actually telling us? Well, it's saying that the average for a weekday, which here is defined as Sunday to Thursday, is about £21,700 of revenue per day. The impact of the dummy is to add roughly an extra £8,300. That's what I call the weekend effect. In other words, the extra sales that we get on the Friday and Saturday are on average £8,300 higher than on a regular day. And that has staffing implications. So our owner might want to bring in some temporary help, because this does look like quite a strong result. Now, I mentioned this problem with the incident. And we can also include a dummy variable for that. Now, this incident only occurred on 2 days. It was one particular Wednesday and one particular Thursday. And again, I've omitted several rows here just so we can focus on the particular dummy variable, number 2 here. So I'm now going to run the regression again with both dummy 1 and dummy 2. And this is the result. We have a coefficient of determination, which is very strong, 84%, or if you use the adjusted R-squared, which is what I recommend, 83%. And that is much, much higher than we had before, when it was only 58%. So we're explaining much more of the data. What we're saying here is that 83% of the variation in sales is explained by the weekend effect, which is dummy 1, and the incident, which is dummy 2. There's been a little bit of a change now. The uplift impact, which was 8,300, I believe. Yes, 8,300. We're now saying is 7,400. But this does give us a truer picture because we're now accounting for the incident. And that incident lost us about £9,600 per day. Now, this is quite a simple example. You will not normally use a dummy variable for a problem this simple. You could argue it's a bit of a sledgehammer to crack a nut. But I wanted to demonstrate the technique. And the technique does not vary whether you have a very simple incident like this or my more complex example with train miles and delays. So what can we learn from all this? First of all, just because the data looks weird, don't just get rid of it. I have come across multinational companies with billions of turnover who say, oh, we don't like the look of that data, so we're just not going to use it. Big, big mistake. You should always try and explain the data you have. And then if it is an outlier, then you discard it. But first of all, you really need to understand the data and examine it properly. As always, the more data points we have, the more observations we have in the sample, then the more robust the results the analysis will be. Now, in this example, the ice cream example, I actually demonstrated the use of dummy variables for a seasonality issue and also an incident. It can also be used, as I did with the railway example, to show if there's been perhaps a change in circumstances from a particular point in time. One example, which I suspect a lot of companies will be looking at, is, say, sales or costs pre and post-Brexit. That's a very good example of a significant change in circumstances where you're not going to have perhaps a single continuous line on the chart. You're going to have some sort of discontinuity, and that's exactly what a dummy variable is useful for. And again, as I demonstrated, you can have several dummy variables. In fact, in one example, I think I used up to 5. So dummy variables are very, very useful in explaining data and persuading people that you have understood the data much more. Of course, the dummy variable will not tell you why there has been a change. It will only demonstrate that there has been one. So that will require further investigation. Well, I hope this little podcast has been useful. Thank you very much. And if you have any comments, put them in the comment section. Bye-bye for now.